Hello everybody and welcome to the fourth installment in the Aorb Tech NumPy series. Today we're going to be looking at NumPy functions. Today we're going to be looking through the Arange function, the Linspace function, the Reshape function, the Ravel function, the Flatten function, and the Transpose function. Let's start by importing NumPy, which we can do by using a code block, and then just running that. First we're going to be looking at the Arange function. What this function basically does is it creates an array. Similarly to the range function, we have the start, stop, and jump parameters, and it's going to create an array for us with all of those numbers that would be visited during the range function. So let's use an example with the variable array. Let's use the numpy.arange function. Then we're going to say we want an array with numbers between 1 and 10. And we want to step by 2, and then we're going to print that array, and let's see what that looks like. So as you can see, it's printed all the odd numbers between 1 and 10. Let's do another example with the numbers from 1 to 100. Let's say array is equal to numpy.arange, and we want the numbers 1 to 100. Since we want to include 100, we're going to put 101, and we're going to leave the step size so we have every single number, and then let's just print and see what that looks like, and we should get every number from 1 to 100, and there we go. That's every number. You can count them if you want. Might take you a while. What the Linspace function allows us to do is it allows us to create a certain number of equally spaced elements between a start and ending point within an array. Let's test that out. Let's create an array here, and let's say it's equal to NumPy, and we want to use the Linspace function between the values 10 and 100, and we want to space them 10 apart. So then this should give us all of the 10s between 10 and 100, and let's see what that looks like. If we print it first, and there we go. We got all those numbers. Let's say we want to visit some decimal values between the numbers 1 and 3. So we can create another variable. Let's call it decimal this time. And let's say it's equal to numpy dot, and then let's use the Linspace function. We put 1, 3, and let's say we want to check 10 different spaces between them. Then we'll print decimal, which is our variable, and we'll see what it looks like. As you can see, it visits every point between 1 and 3, making sure that there are 10 elements, including 1 and 3. That's important. It includes the first and the last number. So keep that in mind, because sometimes you might expect a different result than you get. Let's talk about the reshape function. In previous episodes, we discussed the shape of an array, specifically a multidimensional array, which basically tells us the structure of a multidimensional array and what it looks like. The reshape function allows us to take an array and, if possible, change its shape or rearrange its elements to create a new array that has a completely different shape. It's important to note that the number of elements stays the same. What you're changing is basically the arrangement of those elements. So, for example, you could have a single array with 12 elements inside it. You can use the reshape function to then create a multidimensional array with 2 arrays inside that each have 6 elements. Now, since there are 2 arrays and each have 6 inside, that's 2 multiplied by 6, which adds up to 12, our original number of elements in the original array. So that's how the reshape function works. Let's test it out. Let's start by creating an array. We'll use the Arange function, and we'll create a list of elements ranging from 1 to 21. And let's print it just to see what we're looking at. And that's what we're working with. Now, let's create another variable, array2. And we're going to use the reshape function on our first array. Here is where you have to use your math skills, specifically division, very simple division. We know that in 20 numbers, if, say, we wanted to divide it amongst 4 different arrays, there would be 5 elements inside each array. So we can use the shape 4, 5. And let's print it just to see what that looks like. As you can see here, we now have 4 arrays, each with 5 elements inside. Let's try doing something a little bit more complicated. First, let's create an array. Let's use the Arange function, and we'll create an array with 27 elements inside, ranging from 1 to 27, and then we're going to print it just so we can see what that looks like. And here we go. We have the numbers ranging from 1 to 27. If you know much about maths, you'll know that 27 is 3 cubed, which means that its factors are 3 multiplied by 3 multiplied by 3. We can use this fact to create a new array. We'll call it array 3. And we'll say that it's equal to the result of applying the reshape function to our array that we created. We'll use 3, 3, 3. And what this should create is an array with 3 arrays inside, which each have 3 arrays, which each have 3 elements. And so let's see if our theory is correct. Let's print it. Oh, we need to print array 3. And here we go. We have an external array. This has 3 arrays inside. And each of these arrays has 3 separate arrays. And each of those arrays has 3 separate elements inside of them. So that's pretty cool. You can do some pretty complicated and complex stuff using this function. The next 2 functions, Ravel and Flatten, are both very similar. They differ in one key way. However, their main goal and function is identical. What they essentially try to do is reduce a multidimensional array and its elements into a single-dimensional array. The key difference between these two being that Ravel returns a view of the original array whenever possible, and Flatten will always return a copy of the original array. For the sake of demonstration, we'll be using array 3, the variable that we created in the previous demonstration. So let's go down and create a code block. What we're going to do is we're going to print the result of using the function Ravel on our array 3 variable. And let's see what that looks like. As you can see, we get a list of elements here, and they are all in a single array, as opposed to this amalgamation here of 3 arrays inside 3 arrays inside an array. Now let's go to Flatten and see if it does something similar. We'll apply this function to it and print it. As you can see, it does basically the same thing. Just keep these 2 differences in mind when you're using these functions in your own code. The final function we'll be taking a look at is the transpose function. If you've ever done a course on linear algebra, or if you've dealt with operations on matrices, you'll know how this works. The gist of it is that we swap the columns and rows, or the elements according by the columns and rows in a matrix or in a multidimensional array. To see what that looks like, we're going to have to make a demonstration. Let's start by creating a code block. Inside it, we're going to create a matrix. We're going to call it matrix. First off, we're going to use the NumPy.Arange function. We're going to create the values from 1 to 9. That means 10, non-inclusive. And then we're going to reshape that into a 3 by 3 matrix. Then we're going to print it just to see what that looks like. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 different rows and 3 different columns all going down. So we have 1, 4, 7, 2, 5, 8, and 3, 6, 9. So what do I mean by swapping the elements between their respective columns and rows? Well, it's important to note that the elements that are going down the diagonal from the first element, the very first element on the top left, will stay the same because their columns and rows are exactly the same. But elements which are on opposite sides will swap. For example, 2 and 4 will swap. 2 is at the position of the first row and the second column, and likewise 4, or opposite-wise, is in the first column and the second row. So these 2 elements will swap. These 2 elements are opposite, and they will also swap, 3 and 7. The same goes for 6 and 8. So let's try and use the transpose function to create a matrix, which is a transposition of our original matrix. This is something that you'll find very common in linear algebra and in matrix operations. So it's very cool to see it in code. let's say that we're going to create a variable, and it's going to be called transpose to matrix. And it's going to be equal to the result of applying the transpose function on our matrix variable. Make sure we spell that correctly. And now we're going to print that new variable and see what it looks like. As you can see, it is exactly as we described. The 4 and the 2 have been swapped, the 7 and the 3 have been swapped, and so have the 6 and the 8. And most importantly, the numbers going down the diagonal have stayed exactly the same. So that was the NumPy functions. If you guys enjoyed this video, make sure to check out the rest in our series. If you don't understand anything about programming and you want to get started, then we also have a Python series for you to check out, and we have lots of other series on this channel. You can check out our website, and you can go to our GitHub for all of the source code from this project and from all the other episodes as well. And we have a lot of different socials which you can access all in the description. Thank you for watching and have a lovely day. I'll see you in the next episode.